Well, welcome to the August 22nd, 2023 session of TangerineSDR and the Hamside Technical Session. My name is Dave, KV0S, and this week I continue to learn more about KA9Q radio, digging through setups and learning more about how to put pieces together. I have it consistently running for Whisper for a couple weeks now, so with the newer configurations. So do nightly builds. So that's it for me on that. Next on the list, we have Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thanks, Dave. I've continued to focus primarily on management and also on doing analysis for the MSTID, LSTID paper that I'm working on for the NASA project. I keep trying to debug code and do analysis on that, and it's coming along. So but I'm very glad to see all the good progress that's been happening with this project and with the GRAPE project and with the VLF project. I think there's a lot of really positive things going on, which I'm very excited about.
Yes.
Also, good news, the ham radio station W3USR at the University of Scranton, we now have a build date for the inside part of the RF. So that's going to start September 6th. The contractor, Jeff DePolo, WN3A, he's going to be there putting that in, and the tower, he said, I guess will follow shortly thereafter. There's also some weather considerations, but it's actually being built. The electricians are in there today, continuing to work on the electric and the networking. The RF will start September 6th. And I'm planning, I know Case Western is having on the air shack nights on Thursdays during the semester from 7 to 9:30 p.m. And I think I'm going to try to align Scranton W3USR's operating hours to be similar so that Scranton can talk to Case Western on the air. So that's the goal. All right,
good.
Back to net.
Well, next on the list is Phil, K9Q. Go ahead, Phil.
Okay, what is there to talk about? Let's see. I've been actually tell everybody the truth. I've been kind of distracted in the last week because my lymphoma that I had 9 years ago has returned. So I'm going to be pretty busy dealing with that. Although I also have to keep busy with everything else here just to keep my sanity. So if I have not very responsive, that's why. But I have been working heavily on KNIQ radio, tweaking little things and getting, well, the reports from people who are using it, the primary reports especially, are very useful because it tells me things I have to fix or things I have to document better. And I know the documentation sucks right now, especially after the changes I made integrating the front end into Radio D. But I'm working on that, and any help in writing documentation or certainly proofreading or correcting whatever would be extremely appreciated.
Very good. Is that it for your report?
That's it, unless somebody has any questions. I got to get out of here. I'm going to leave in maybe half an hour to go to a local microwave group meeting. It's always Mondays at 7 o'clock.
Okay. I don't hear any questions, so let's go ahead and next on the list, we have a phone number, and they have their mic muted, so I guess they're just listening in. Then we have Michael, AAAK. Go ahead, Michael.
Oh, thanks very much. Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to the net. I've been doing some work with the NASA project on the FFT analysis of LSTIDs, and was really focusing a lot on preparation of the GRAPE image that we're going to be rolling out soon. Burned about 4 hours today simply trying to get the program to start automatically after a boot. And I tell you what, I've been through documentation, tried at least 20 different ways that they claim work, and every one of them has some kind of a flaw with it. So if somebody would like to get with me offline sometime and spend a couple of hours working with me on that, because I'm getting stressed because they want to start sending these images out imminently. And I think that's one thing that's pretty important, to have it restart after a power off. So I had one image that will do that, and somehow I can't reproduce it. So help. Anyway, that's my report.
Well, surely somebody can help you. Next on the list is Bob N5BRG. Go ahead, Bob.
Yeah, hello, everyone. Making some progress here. Just get an hour or two in the mornings to work because of the heat, but I am getting there. So back to you, Dave.
Okay. And next on the list is Dan N4XWE. He's had a busy week. Go ahead, Dan.
Hi, Dave, and everyone. Well, went to the Huntsville Ham Fest this weekend, which was quite exciting. I've never really been to a ham fest in a town where I lived, so that was a first. And other than that, and doing some stuff for Tapper, it's been rinse, spin, repeat about all week. So back to you, Dave.
Very good. Next on the list, let's see, Dave McGaw N1HAC. Go ahead, David.
Hello, everyone. Have to admit, I didn't do much on our side of things because I was doing what you might call terahertz receivers, otherwise known as telescopes. But there's a remarkable crossover between hams and telescope making. But we had the Stellafane amateur telescope making convention this past weekend. Very well attended. Certainly have recovered from COVID. We become the largest campground in Vermont the weekend that we put our convention on, and had a very interesting keynote talk by Joe Rao, who's a eclipse chaser and a weatherman. And while I didn't get to talk to him about our endeavors, he was pretty well mobbed at the time. I did put up had some of the cards for our SCQP and all that, and talked it up. So hopefully we'll have some new converts. And back to Nat.
Very good. Next on the list, we have Ed N3ED. Go ahead, Ed.
Hi, I'm currently attending the STERA conference down in Green Bank remotely. They're doing some really interesting work in radio astronomy, and there may be some cross-link that HamSci in general can do with that. And I'll probably talk separately, maybe to Nathaniel about it later.
Okay, well, thanks for that report. Next on the list is Franco K4VZ. Go ahead, Franco.
Good evening, everyone. This weekend we had the International Lighthouse and Lightship Weekend. So I tried some FTA there over at St. Augustine Lighthouse. And on that, I've been working on the little module for GNU Radio they're going to show in a little bit. Back to Nat.
Very good. And I look forward to that. And next on the list is Gary AF8A. Go ahead, Gary.
Good evening, everyone. I've just been trying to make some progress on the Grape One project. That's it. Back to Nat.
Okay. And next on the list is Hillman KD2 MCR. Go ahead, Hillman.
Hey, good evening, everyone. Nothing too much to report. I'm still working on the paper. Getting there, still working on it. Hopefully I can get it done soon. But other than that, there's nothing too much to report. So back to the net.
Okay. And next on the list is Joe, W7LUX. Go ahead, Joe.
Busy on other projects. Grape still cranking out data. Everybody have a good evening.
Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It's been a pretty busy week for me. I replaced the GPS timing receiver in my VLF system that's running at Nathaniel's house. It failed again, like the first one did, where it would it wouldn't operate as a GPS receiver, but I could set and query configuration options, and it wouldn't output a PPS. I don't know why this is happening. I've contacted the one distributor that distributes Trimble, and I've asked their support, and they haven't heard anything about this. The only thing that I could think of immediately would be the elevated temperature inside the case. That's the only thing that I could think of, but I don't really know if that's what's causing it to fail. Since I'm not a big company and ordering 10,000 units, it's kind of hard to talk to ProTempest to get them to give me an answer. So I was able to order a new unit instead of having the Trimble sticker on the can. It had a ProTempest sticker. For those who don't know, the company ProTempest purchased Trimble's timing division. So all of their timing receivers go through them. But I was able to successfully replace the receiver and got everything up and running. I am also I also started work on my VLF transmitting rig, my EBNOT rig. When I transmit messages over VLF, I use the EBNOT digital mode. So this rig consists of a Raspberry Pi, a sound card, and a GPS receiver. What it does is it takes a message of about 5 characters or however many characters you want, and it encodes it using a synthesizer program. So what it does, it'll synthesize a GPS locked carrier, and it also GPS locks. It also synthesizes the phase changes in the EBNOT mode, also locked to GPS. So you have an option to send an EBNOT encoded message on a GPS locked carrier, or just a GPS locked carrier, because carrier transmission is also done at VLF. Lastly, I just want to show you guys quick some really cool stuff. This is an elves event. It's a halo. This is a transient luminous event, often referred to as mesospheric lightning. What it is it's an ionization of the gases in the upper mesosphere due to a lightning impulse. So this was an ELVS event that was generated by a negative 327 kiloamp stroke that came from one of the tropical storms by Puerto Rico. So this was a beautiful capture. And then, what I was able to do I was able to look up the data in I was able to find the specific stroke on my VLF system. And this is the time domain plot. And what's interesting is that you can see this little ELF tail here, this ringing after the initial impulse. So what that is that's often what's called an ELF slow tail. So ELS events are often are generated by very powerful lightning strokes, and they often have continuing currents. And lightning strokes with continuing currents typically have an ELF component, and this is what's seen here. At the same time, VLF receivers, there were other VLF receivers that captured this event in Europe, and their ELF component is much longer duration, so there's more ringing, and that's because of the longer the propagation distance, the more ELF component that you have in duration. So that was really cool. Frankie, who usually captures these events, he captured a really nice one. Lastly, I don't know if I mentioned this in the last meeting, but I was able to send a Trimble resolution SMTX to the author of GPS Daemon. GPS Daemon is a open source GPS program that will that will speak binary or NMEA. It'll talk to GPS devices over serial, and it will put that information over a network socket. So any program could actually access that data. And it's also used to transfer timing information into NTP daemon. And that's how I use it on my VLF system. It's kind of underutilized by the members of HAMSI. It's a very useful program. And I would like to see more use in the HAMSI community, specifically for Stratum 1 NTP servers that are used on these capture systems. That's all I have. Back to the net.
Okay. Next on the list, we have Rob, AI6 in VN. Sorry, Rob. Go ahead. Is Rob still there? Or? I see his light off, but I don't hear him.
Do you hear me now?
There you are.
Okay, I'm sorry. I thought, multiple audio devices and computers just don't work together very well.
Yes.
Let's see. Well, I came back from Maui on Wednesday and managed to contract COVID. So I'm in quarantine. So suffering mostly now from a severe sore throat. So maybe I'll talk less than I usually do. I think one of the major things that we'll continue to work with Phil and I on the AAA. I think we pretty well established that that it works with a Orange Pi 5. You can do that, but you can't do decoding or anything else on an Orange Pi 5 at the same time. We tried to get a real-time kernel for the Orange Pi, but that was we determined that it was kind of not the best use of our time. So Jim Lill, who I think many of you know, it may be working a little bit on that. But in the meantime, if you have a Triple H, you ought to plug it into an Intel processor if you want to do serious work with it. And so that was kind of a unfortunate detour into Linux kernel building and such. But I think we've established pretty clearly that the 888, when properly configured, works just as well as the Kiwis, which are well configured Kiwis, and they are so that in terms of total number of spots counts and the SNRs that are obtained from the two. So we have a comparison site, several, but probably the best comparison site is Tom Paratori, WA2TP, who is one of the top whisper spotters in the world, and he has a GPS discipline Kiwi and a 888, each are fed by the same RF signal, and he gets identical spots from them. So that was always kind of a little lurking concern that we haven't really validated the quality of it. So there seems to be a lot of good aspects to the kind of hidden aspects to the 888 design. So in designing the one thing that has come out is that it seems remarkably stable and remarkably accurate and low phase noise. So they must have some kind of a ovenized or temperature compensated and trimmed oscillator inside the 888. So because geez, 1/10 of a hertz accuracy on 20 meters, and the spreading numbers are they're not as good as the Bogner. I mean, the Bogner in essence is perfect for our purposes and our frequencies. But spreading numbers, with our ability to measure in essence, the Doppler shift or motion or phase noise of the oscillator is limited by the sample size of the whisper, 120 second packet, and so it's about 5 millihertz, and the 888 spreading numbers are maybe at most 10 millihertz. So these are not GPS discipline; they're just what comes out of the box in the when you open your 888. So anyway, it's remarkably good. Phil made some efforts to try to calibrate, measure the actual oscillator frequency, and then modify in his signal processing, modify the signal to compensate for that. And I think they were not particularly successful. And I encouraged him not to work on it.
They're successful with annoying artifacts. I don't fully understand. So I certainly recommend going in with an external reference if you can.
Yeah, I think that it's a much better use of your time to work on other things. So it's I mean
there's a lot to do.
We have a lot to do, and Bogner's or perhaps this new reference design, that Tapper I think John Ackerman is working on. I mean, I think we're just better off focusing on using those rather than trying to work around the characteristics of that. There is other news. Is for those of you who are interested, there's Paul Elliott, WV6CXE, has now 6 of his Beacon Blaster 6s. These are the transmitters that are simultaneous 6-channel transmitters. There are a number of them are claimed. I'm planning to use 2 of them, one in Winnemucca and the other in New Mexico. But I think one is going to Costa Rica, also along the path of the annularity. So, but if this is of interest, I would, you could contact Paul, his Turn Island Systems website describes the Beacon Blaster 6. So it's a, obviously GPS stabilized. It's and that's phase locked GPS. So it's a wonderful frequency reference for the eclipse events. And he also has a quantity, I think the order of 50 of low pass filters. I think, Phil, you had asked for one. These are 30 megahertz low pass filters. They also have an optional shelving filter. It's an option, jumper selectable option that suppresses up to 15 dB below 10 megahertz to compensate for the increasing the noise figure problems of the 888 and the Kiwis and others. So, and of course, if anybody's using a 888 and you're going to run it at 64 megahertz sample rates, you're going to have aliasing problems with your local highway patrol or other users of the FM bands. Those signals in the 30 megahertz to 60 megahertz range. So you need you'll want to have a low pass filter, and Phil has done a good job. I'm sure he's had this manufactured by JLPCV, so they're I think they'll be reasonably priced, and should be available soon. But I think those are anyway. That's all. That's I think all I can think of right now, and my voice is going out. So back to
Okay. Well, sorry to hear about the illness, but we're glad you're back.
that. Marvelous drugs.
Yeah.
So I'll be okay. Just
Okay.
I'm comfortable. But.
Okay. Next on the list is Tom K7 ITM. Go ahead, Tom.
Hey all, so this is my first time here. Somebody suggested that you guys might be interested in somebody that has some SDR receiver design experience. I used to work for Hewlett Packard and Agilent, and at Agilent designed perhaps the first commercial receiver using the analog, well, now it's analog devices, the LTC 2208, back when it first came out. And my experience before that, shortly before that, the Hewlett Packard 89410 signal analyzer used initially a 12-bit ADC. It was designed in the mid-90s with dither. And the ADC that we were using, it went obsolete, and they enlisted me to redo that. I did dither insertion and extraction that was pretty darn good. Got a very, very low noise floor with it. I actually would love to be playing with an ADC that isn't dithered but is otherwise better than the LTC part, and put my own dither around it and removal, and see if we couldn't even do a better job than it does. But I don't know that you guys really need that. Anyway, I would be interested in helping out with the receiver. I guess I got to learn a lot more about what you need, but that's my introduction for now, I guess. Back to you.
Very good. The fellow who's doing some layout is Dave Witten, and he's on vacation right now in Europe. So he should be back in a week or so and joining us. So please come back and we can talk about that. There may be other people that want to talk to you as well. Very good. So, does anybody else have a question? Well, next on the list is Tom N5 EG. Go ahead, Tom.
Oh, good evening, Dave, and everyone in the group. Been a productive week. Thanks to Franco and to Phil for all their help. I've got the RTL receiver on the Raspberry Pi talking and sending raw IQ packets over the network to an Ubuntu machine and into GNU Radio. And there were a few little gotchas. I think we got those all figured out, or most of them anyway. And so it's been a good week. Back to the group.
Well, very good. Tom, appreciate the report. And last on the list, we have Robert Troy. Go ahead.
Good evening, everyone. Just been working with KNIQ to interact with GNU Radio. About it.
Okay. Well, welcome.
I should point out that Rob is one of our students here at the University of Scranton, and he's been the summer student who's been working with Majid and working on getting some of that stuff Scranton. So I know he emailed some of you last week, and he was very excited to get to meet people on the Zoom this week.
Very good. Well, unless you have more comments, we're through the list and open for general discussion.
I think Franco may have a demo for us.
Yes, Franco, you want to go ahead with your demo?
Whenever you guys wanna, I share my screen and show you a little demo I have of the interaction between GNU Radio and KNIQ Radio to show, the little module I wrote. So let me just share my screen here, and can you see it?
Yes.
Okay, and it's readable?
Yes.
Okay, perfect. Okay, so let me get started. So let me explain, first of all, what we're looking at. So we'll explain better way. So first of all is I'm working off my, I'm connected to Zoom off my Windows laptop because the camera only works on Windows. So that's where you see me. However, I do most of my development on my Linux desktop, which is a Fedora Linux. So what you are seeing in this window is an RDP section against my computer, and everything we're going to runs on the computer. RDP is good enough, I think it's going to be. However, I haven't figured out a way. Actually, I wasted too much time yesterday with RDP to share the sound. So what I did, I put a little speaker next to the computer here to my laptop, and I will play the sound of the desktop computer, and hopefully you guys can hear it from there. Okay, so that's kind of a little hack here. The other thing I need to say is that I do not have an RX888, but I've been using a KNIQ radio with an RSP, SDR Play RSP DX. And this radio is, connected here. I don't think the current version of KNIQ radio supports it, so it's a little older version with little differences, but I should give you a good idea how the whole thing works. And of course, I'm willing to help, in case someone has problem with that. The one last thing is this antenna I have is an antenna that is just a 2-meter stick. So it only is good for VHF and doesn't really go for HF. And especially in my office here, there's a lot of RFI. So we won't be doing much HF here, just to show you what I do. Okay, so now let me get started with the demo. So first of all, I have 3 examples that I put in my repository. I'm going to send a link to the chat after I'm done here. And I'm just going to run this example explaining what I'm doing. And so the first thing I want to show you is what I have currently in the front end configuration, which in my case is strplay.conf. And I have a fixed frequency of 162 and 48 kilohertz, which is around the NOAA. So we're going to listen to some NWS National Weather Station because I know they're always on. They're on VHF, so they're pretty good for this example. And the first flow graph I'm gonna, and everything is ready for this case here. The first scenario example I want to show you is a scenario where we're going to look at directly listen to the FM station. So let me show you what I have in this radio D that we're going to use now for this first example. Very simple. So mode FM, sample rate 24 kilohertz, data, on and all the frequency. This is pretty much, same as it comes from the K9Q radio distribution. So there's not much to it. The only thing, of course, I have my input, my front end set this way. Now it will be different because of the new version of of K9Q radio, but it's you get the idea. The first thing I always do here is to run this monitor program to make sure that everything is set up correct. And that's probably one of the issues at the beginning is to figure out everything. So I'm going to run monitor here. Actually, let me open up on this window here. So I see here. Let's see, how can I copy and paste? Probably I need to use, with RDP, I'm not sure how the keys are mapped. Okay, it did a poor job here. Okay, so let me see. And we should be able, did I start everything? Let me make sure because I started.
That error message is normal if radio D is not yet running.
Yeah, exactly. That's probably what I just want to make sure that I did because I thought I did before, but again, let me just make sure I have SDR play running here. Oh gosh, no, it's okay.
Yeah, give the instance.
Yeah, I just need to get the name of the.
Actually, it's radio play at.
Right, no, but I just want to make sure I have the front end running, Phil, because I have. Okay, so the frequency is correct, is running. So let me just.
Okay, that's right. You're
Yeah, I
so
want to
used
just check the front end because I didn't remember. Now I had. Okay, and then I should be able to see here. Yeah. Okay, let me start it. Okay, so let me make sure it's up and running. Sorry for the inconvenience. Okay, as you can see, started all the 70 milliliters, so now I should be able to run it again, and it should.
Their monitor came up once it resolved the output stream.
Yeah, it should show that usually I see the channel here, the SSRC running.
Yeah, the stream should all show up at this point.
Yeah, yeah, of course, tonight it doesn't work. Gosh. It's always the moment of, okay. They should show, I mean, they were showing up earlier, so I hate this.
Oh,
because I see them running. Let me see.
Latest version, by the way, gets rid of all those really annoying error messages from also.
Yeah.
Yeah,
I see this running. Hold on. I just want to make sure that this is running. Yeah, I may just restart both of them and see if it helps Phil, because it should have been okay. Let me just stop and see if it comes up.
Your audio system is working, because it looked like it bombed out because it couldn't find an audio device.
Oh, it's all because RDP. Oh, this is crazy. Then I see now why. I didn't think about that. So it may be, yeah. It may be the reason why, because RDP doesn't. This is not gonna work then. Okay, so let me show you. Yeah, RDP then has a. Okay, so, and it didn't. Yeah, so that's a good point. Okay, so we may not have a good demo at least tonight because I forgot about the need to have another device connected to that. Anyhow, so let me just show you what it looks like and then, okay, so this is the GNU Radio, flow graph I wrote, which basically has just a source here with the address and the RTP source, and this is a sync, and now I'm suspect it won't work. I mean, it won't work. It won't be able to hear any sound, so just gonna run it and see what happens. Yeah, I thought I would hear the sound on my speaker, but RTP doesn't. Let me do that. Actually, no, it doesn't show the.
I've been waiting for this addition to GNU Radio for a long time.
Yeah, I guess now everything is. Let me see. Should be here, and it should be finding. Why not? Did I crash it?
Okay, Radio D is not running yet.
Yeah, that's what I'm afraid happened. Status.
Yeah, this gets a lot easier with the new version because there's only one daemon.
Yeah. The new version should probably be. I'm gonna try to restart again and see if I can get. Otherwise, it's gonna be okay. Resolve. Oh, it's okay. So the backend is not running. Okay, let me check the backend. Okay, it failed. Oh, gosh, this is not gonna work well. Okay,
I could demonstrate mine, which is receiving. I actually have a whole bunch of Radio Ds running, and then I could run monitor and show all of them.
Okay, you can probably do that because I just let's see. Usually this should be okay. Let me start again one more time, and then if it doesn't work, I apologize. I didn't think about the complexity of RDP. Okay, let me see if it comes up.
On if people are interested.
Yeah, it started up. Let me start. Oh, here we go. Okay. Okay, here can you hear? Gosh, it's not. RDP is awful. Yeah, you should be able.
It's coming through your microphone. It's not feeding to the share.
Yeah, it's and it's choppy here. It's all the whole setup is not really. But anyhow, you should be able to hear that. Let me show you the other flow graph quickly, and then I will make more interesting for this. So I'm going to stop this one here. The second
Before you
one
share, if you check share audio, we would be able to hear it, I think.
Oh, let me see, because it's not, okay, it's RDP is remote, so I don't think I'm sharing the. Okay, can you hear it?
We're hearing pieces of it. We believe you.
Eh?
There it goes.
Sonic storm. Coastal water forecast for Alpha Island flag already out 20 to 60.
You don't hear it?
Yes.
Southeast winds 10 to 5 to 10 knots.
Could you hear or not?
Yeah.
We can hear
okay.
It was going directly, but we could hear it.
Yeah, it was through the microphone. Let me show you the other flow graph here. I'm gonna stop this here because I changed it. So the second example, it uses what we call. We're gonna do pretty much the same thing, but now we're gonna use an IQ stream. So I create another one using IQ, and this is very simple. Again, we're just passing an IQ and the same frequency and same everything else. So I'm gonna stop the other radio D and start the one with IQ. Okay.
You could run them all at once as long as they don't conflict in their use of the tuner.
Yeah, this is just a quick and dirty, but you can see that the modulator started. I'm gonna start a slightly different flow graph here in radio. Okay, so here we get the IQ, then we have a narrow band FM receiver, the frequency sync, so we should be able to see the frequency, and then the volume here set up at 500 milli times, and then the audio sync. So let me show you this one here. So we got the IQ here, and which is a complex of course signal, and we play that here. Hopefully it will work. I don't know if you can hear me.
There seems to be a separate audio sync specifically for a
Yeah.
Zoom mixer. I don't know if that works, but anybody ever tried that?
Mhm.
In other words, there seems to be a synthetic or a output device called for Zoom audio that you can redirect, or if you select that as your output device, I guess it'll go into a Zoom conversation.
The problem, Phil, is that the audio comes out from my desktop, which is not how I connected to the Zoom call. I'm connected from the laptop.
Oh, I see. I see.
Yeah,
So
that's
let's
why
see.
it's all a hack here to get everything together, and that's why the audio has to come from the speaker that I have here in front of my. So this little speaker here is where because it's
I
connected to
see.
the
Yeah.
computer
So
where it
it's
runs. Huh?
speaker, the microphone. Yeah.
Yeah, I wish I had a way to get RDP to work with audio. It wasn't, I mean, and the last one I want to show you is a whisper case. So let me just, again, all the examples are in the demo. So in this case, I changed the configuration a bit again. Okay, so let me just show you what we're gonna do. We're gonna stop this guy here. Again, probably they could run all, but Whisper, for instance, I used a configuration here where I set the frequency to the 20 meters band here. So we're gonna do Whisper there. Again, I have a very poor RF, HF, so it's gonna be not very interesting, but I just wanna show you how it works.
Yeah,
So
a
I'm gonna
comment
stop.
on setting the frequency of the front end. You don't actually have to set it there. It'll be set automatically when the RDOD comes
Oh,
up.
okay.
We'll
So
tune it
that's
where it has to
thanks,
go.
Phil. I didn't think about that. Yesterday I was just playing around. I was just, hacking
Yeah.
things.
That feature of frequency setting in the hardware control file, that's so you can set a front end tuner and lock it in place so that you can't
Oh,
inadvertently
okay.
move it. That's all that's for.
Okay. So then I was just playing again. I apologize because I was just hacking that, but it should be working this way. Let me see if we can get Whisper now. Okay, so let me make sure that is running. Oh, by the way, this is the configuration I used for the Whisper in Radio D. It's pretty much taken from the K9Q radio, the frequency here, but only we're interested only in 40 meters, in 20 meters, of course. And I have a little flow graph here for that example.
Now, if you've got more than one, if you've got multiple receiver channels that conflict on the tuner, which one gets it, which one wins is random because these threads start up
Oh,
in
I see.
determined order.
Okay.
So yeah, what I
again,
usually
this-
do, if I have a tuner that they can't cover them all, I'll just disable all the ones that I don't want to start up. You say disable equal Y in that section and it'll disable it.
Yeah,
This is why
that's
the
it's a good
RX-88 is so
idea.
nice.
Yeah, and again, if I run this, again, I don't have any sound here because you can see the frequency here should start showing that basically there is no signal here to be heard because it's Whisper and it's USB, but you can see the 3 kilohertz filter, pretty clearly. So the signal is received as K9Q radio sends it out. You can
What are
see
you
that is.
what are you setting into it? You're setting baseband audio PCM, is that right?
Yeah.
Okay,
So
yeah,
you can
yeah.
see,
So it's flat from 0 up to 3 kilohertz, which is what actually
right,
from 50
and
hertz
that's what
up
I
to-
want to show you. There's not much to
Yeah.
hear, unfortunately, in my house here, the frequency, but you can see the right, the right filter is shown in here. So I
Yeah,
know
you can
it's,
play with that filter with the control interface. You can go and change that filter if you want.
yeah, I can see if control works. Let me see if I can get it to work.
So 120 dB, that's a pretty good. Wait a minute, is that relative to 0 dBFS?
I don't know, honestly. This is, no radio, pretty much straightforward here, and I don't know exactly what.
Yeah, I was just wondering because I'm sending it 16-bit PCM, and I scale it so well it runs from 0 dBFS down to about minus 100.
Yeah,
as far as it can go in 16 bits.
and I didn't modify much else. So is control is like here this, right? Whisper along.
Yeah. By default, I target the output level at minus 15 dBFS, but that can be changed. So it
Oh,
looks like
okay.
the relative gain here is not what it's relative, not absolute.
Yeah, probably that's what it is. But I just want to give you a demo of the things that are possible. I apologize, it was not really perfect. There are a lot of issues, but just those are example in the repository, and I think it's you can try and see how it goes.
That's cool. I've been waiting
Oh,
for
the other
that
thing I want to
feature for a
show
long
you,
time.
important, whenever something works, you will see this message here. So if you don't see a message like this, it means that it's not able to, it tells you which kind of PCM and which type of RTP is that. So for instance, for the IQ was stereo here, you see, because you got two channels, and for the here. And of course,
Yeah.
if you want, you can also change the type here. I'm just going to play around. In the block, you can change the type here from mono to complex if you want to go again IQ, or interleaved short. So if you want to just use the shorts, but they interleaved IQ, and so on. So, and of course, also for stereo and so on. So that's pretty much what you can do.
That's
Okay,
pretty neat.
I think that would be a good idea, in case someone wants to integrate with GNU Radio, to get started, to get.
Can I have the screen for a minute if you're done with your demos, Franco?
Yeah, and I thought I closed my screen.
Okay, yeah, all right. Let's see if this works. I think this is the right window. It better be. Yeah, okay. That's the output of my monitor program looking at all the local FM channels so that I can see here in San Diego. This is actually the output of 3 separate radio Ds running on 3 separate Raspberry Pis, each one with an AirSpy R2, looking at the 2 meter, 125, and 70 centimeter bands. So yeah, it's well, this is Southern California, so what do you expect? Let's see. Can I change the sizes? Yeah, good. Okay. If I widen the window and hit the V key, I get verbose information. But this is really, useful only for basically debugging RTP, seeing how many packets are getting, how many being dropped, and so forth. I'm running this over Wi-Fi, so it's not as solid as a wired Ethernet connection would be. And at the bottom, I have some more data. I'm looking at comparing the clock speed with the incoming data rate, counting how many seconds there's been since I dropped the packet. The latency, I'm using the port audio package to actually drive the audio output. So some of these parameters are from there. When you play out an audio stream, you actually want to listen to it. You need something called a play out buffer, because the D to A is being clocked at its own rate, and that's independent of whatever the front end is. I mean, oscillators have gotten better, but there can still be offsets. So by default, I start that buffer at 100 milliseconds, and then whatever comes into that buffer, you can see. But if it underruns or overruns, then I have a reset command, or actually a way of automatically resetting it to put it back to 100 milliseconds. That's probably the most challenging part here. Now I have all the channels muted at the moment. Let's see what happens if I unmute one. Does anybody hear anything? Nobody hears anything, right?
No, I don't hear anything.
Yeah, I've never tried this before, but I directed the output of this into a device called Zoom. Let's see. What did I do? Yeah, it gives me a whole list of output audio devices, and I found one. Wait a minute, I'm sorry. This is running on one of my Unix machines. Sorry, I meant to run it locally, because locally here. There we go. Zoom audio device. Let's try this. Let me redirect the output into Zoom audio device. Oh no, and the notch option. Anybody hear anything? No?
No, yeah.
Okay. Well, I guess that doesn't work. I was thinking maybe it was a mixer for sending audio over. But you would be hearing all those channels right now.
Oh, wow.
I have a feature that automatically notches out PL tones. They got annoying to listen to for a while. So anyway, that's what's active right now. The S key periodically resorts it in terms of, most recently active. Verbose key again.
Yeah,
I can
yesterday
listen
when
to
I was
multiple-
listening,
I can
sorry, go
listen
ahead,
to
Phil.
multiple streams if I want to, like my HF receiver at the same time. So I have 4 radio Ds running all the time. The HF receiver is idle at the moment. It's running, but I don't have any active channels. Unless I pick the WWV chunk. I have WWV modulators running continuously. If they'll show up. Huh. I must not have them enabled at the moment. They generate a lot of bits. So anyway, the play queue is the number of milliseconds the stream has in the output buffer to give you an idea whether the clock's running fast or slow. And the one thing you do with FM is that every time a squelch closes, you can reset that play out buffer. So small clock skews are not a problem with an FM channel where the squelch is frequently closing. Anyway, that's it.
I would like to recommend that if people haven't seen it, you gave a nice talk to your San Diego radio club demonstrating most of this.
I'm really curious about this Zoom audio device that I see. Yeah, if I redirect it back to my speakers, I hear it. I don't know if that's coming through, but
Yeah, I can hear it now.
yeah.
Got one of those.
Let me mute everything for a moment. Notice the pan column up here. When you have multiple channels, as a hack, I assign them
You
random
lost your
locations
screen,
in the
Phil.
stereo spectrum. What?
You're
You
not
lost your
sharing.
screen.
Oh, I'm sorry. Thank you. I meant to do that. There we go. Yeah, note this column marked pan. That's a stereo pan. So when multiple channels come up, I kind of semi-randomly assign them locations across the stereo spectrum so you can tell them apart. You can also move them back and forth like this with an arrow key. And you can change the gain of individual channel. Well, one's muted right now. I can change the gain with the plus and minus keys.
Oh, for sure. But that was.
Oh, I can hear it.
So, let's see, SSRC, tone and notch, current total and activity in minutes and seconds, and the play cues I mentioned before. So it's interesting when this link repeater system called the Papa repeater comes up, and you happen to have this on, you can hear about half a dozen repeaters at once at different places in the stereo spectrum. It's like sitting in a stadium with somebody talking over the PA system because the delays are slightly different.
Yeah, I can monitor a dozen repeaters around here, but there's no traffic on any of them, so.
Yeah.
Don't hear
Well,
anything.
even in Southern California, I mean, there's not as much traffic as there used to be, but there's so many repeaters and so many of them are linked that it doesn't take many conversations for there to appear to be a lot of activity.
Something completely peripheral. I mentioned, I noticed you have Mount Palomar, a number of repeaters coming from there.
Yes.
The founder of our club, the Springfield Telescope Makers, is the same person who drew all the fantastic drawings of the Palomar telescope, the 200-inch.
Ah. You know, I've never been up there. I've lived out here 30 years. I've never visited the Palomar telescopes. I've been up Mount Palomar, but I haven't seen the telescopes.
Yeah, you might say he was the CAD system back then when it was being
Yeah.
built.
Anyway, if I'm
Russell
going to make
Porter.
that microwave meeting, I might as well go now. So good talking to you guys. And
Thanks,
I'm
Phil.
anxiously
Very good.
awaiting that 30 megahertz low pass filter. My mini circuits filters are not good enough to get rid of the California Highway Patrol, at least at the lower sample rate. So I actually changed the sample rate and moved them away from WWV on 25 megahertz where they were.
What are you
finer.
using for filters?
Those mini circuits, 30 megahertz low pass filters.
I've
I
found
mean, you know,
putting two of them together actually is
I
quite
do have
good.
two of them. I'm concerned about making my noise figure even worse up there, but
No, well, the loss is very good.
okay.
No, we use them and like we'll band limit at 5 megahertz and below, which is what we do for our ionospheric research. And I'll put two of them together and actually makes a pretty nice filter.
Okay, well, I should get twice as many dB. I mean, I've seen the curves. I mean, they're not exceptional, but I'm sure the filter that Rob's friend is working on will really help, especially if it's got a nice. I don't know what the design of low pass filter is. It's got an elliptical shape or something like that. It'll fall pretty rapidly above 30 megahertz, which is what you want.
I'll have to see if Coilcraft has a 30 megahertz version of their filters. It's another
Actually,
one.
what you really want is an option to choose 54 megahertz. So, because if you're going to run this thing at full sample rate, it'll give you 6 meters. You know, why waste it?
Yep.
But you
No.
do want it to fall pretty quickly above that, so you don't get TV channels or FM.
Sure.
There is
Well,
a
maybe
lot of
one
low
of us
band.
should design one of those. I've done a lot of filter design. It's not that hard.
That would be
I've
great.
made 16-bit good filters for RF
Yeah,
work.
let's see, at about 130, that's the 65. And what's above 65 megahertz is a couple of TV channels and FM. FM would probably be the big problem. There aren't very many low band VHF TV stations anymore since the switch to digital.
No, and the ones that are low power.
Yeah, but the big problem around here is going to be FM. Those stations are pretty strong, and they're not far from me.
Yeah, but that's far enough above, and you can, if you
Yeah,
do an
they're high
elliptical
band
filter,
VHF.
you can set some poles up there.
Yeah, 180 and 188 megahertz. This channel's
Zeros.
8 and 10, so they're high enough up that you can probably get rid of them.
Yep.
But I'm really looking forward to that filter. I mean, Rod's been calling it a shelving filter, but you could really call it a pre-emphasis filter because it's kind of doing the same thing, you know, boosting a signal to high end to overcome noise. Same idea, but you know, the shape is different.
Well, you need
nature of the noise is different.
you need an LNA in front of it.
Yeah, yeah.
To make it to make it kind of 10 dB of net gain at 30 megahertz, and then 15 dB or more of attenuation down below 10 megahertz. And so but Paul just did the filter design. It was easy for him to fabricate it. So I suggested this morning that he just send them to me, and I'll handle them and distribute them to people who want them.
That'd be great.
So
one thing I did to improve my noise figure at the high end was I simply added an AM band stop filter, and that took my raw A to D input down from about -25 to -37 or something like that. So I just added more gain in the RX-888 to bring the signal back up, and that should also improve its noise figure. Because most of the crap that was coming in was AM.
Well, that's an experiment that I want to try. It seems that the VGA is spec'd at a 7 dB noise figure, but I think that's it probably at its maximum gain setting.
Exactly.
And you're by default, you're not setting it. You're setting it for the high range, but you're not setting it for maximum gain in the high range, right?
Right. I can't because the AM broadcast stations would overdrive me. That's why.
Well, that's why you have well, you can get those little $15 filters from.
And that's
RTLSM.
exactly what I did. That's
Yeah,
exactly
they,
what I
yeah,
did.
they suppress the AM band by 20 to 35 dB, which is generally enough. It wasn't enough for me in Maui.
And it still won't even stop you from doing any AM DXing, because the
Oh
noise
no,
level-
it doesn't. Yeah, well, I had a really good one that blocked everything by 90 dB, and then people started complaining they couldn't listen to the AM stations on the Kiwi. So yeah, you want to block it enough that they don't overload you. But I think 30 dB of suppression is enough. But
Yeah.
But
whether you're next to a 50 kilowatt station or not.
well,
That's right.
In Maui. I'm 5 air miles from a 5 kilowatt station, but I'm up at 1,200 feet, so I'm probably right in their major radiation lobe, and so I would get,
They're pretty much flat to the horizon, whatever.
yeah. So it's
But we put our instruments very
the-
up and next to, very near, within miles of an AM broadcast station. We have to notch it out. We're also,
what's the call sign of that station, Rob?
which one in Maui?
The one in Hawaii. Yeah.
Oh, geez, I don't recall. I have to go.
I was
look.
going to look it up and see what their pattern was.
Oh, well, I can find it for you if you just wait a second. It's
5 kilowatt stations usually Omni.
I don't know. A lot of them are directional. Well, actually, Hawaii is probably different. You only have to protect other stations in Hawaii. Who else is around?
Yeah, it's
Yeah, and like even the 50 kilowatt ones, they'll be Omni during the day, and then at night
Yeah.
they go into the pattern.
Usually, yeah, that's very common.
out at let's see. Yeah, here's your radio locator. Tell me it's that's not FM. I want the AM station. But yeah, it's KNUI in Wailuku.
Yeah, I'll look it up later when I get back. All right, guys, I'll see you.
Yeah, I mean they were so strong that we had to really notch it. We did a notch at 550
Yeah,
kilohertz, and
that's the only way.
that got rid of the problem. So anyway,
It's non-directional, by the way.
it looks. I don't. I think they have a single tower.
Yeah,
Right in
Okay,
that's
that
it.
means they're non-directional.
No, but I mean, just even going to Wikipedia, it's 5 kilowatts non-directional antenna.
Anyway, yeah. I mean that was
And that's basically a quarter wave pattern,
yeah.
vertical quarter wave. So
Yeah.
very broad.
Well, okay. Well, Phil, you saw my note about Glenn's N6GN's interest in the synchronous, dual input.
Yeah,
project.
yeah. You guys don't quit, do you?
No, we're not gonna. That should be an easy one for you though, compared to the one that I'm really interested in.
It's just
time
the
of flight.
torrent of data that I have to handle, right? I mean, I just got something that can handle a 2 gigabit torrent of data. Now you want more.
You gotta I think you have to have two. You're gonna have to do it on one machine, right? You'd have to have two USB 3 inputs.
Well, I don't know. As long as they're time stamped, you could probably spread it out.
Yeah. Well, that's but you would be responsible for time stamping it. How would you get it from if you record if you do your FFT, you would have to somehow associate your FFT with by the time you do the FFT, you've lost the stimulus though, haven't you?
No. I mean, you can just run a 1 PPS into every antenna simultaneously. And I count samples from there, assuming the clocks are all synchronous.
Well, okay. Well, if then it would be your job to figure out from how to move the data from consolidated and right in one analysis machine, radio D machine.
Well,
And-
the secret there is you try to pare it down as quickly as possible. Cut the sample rate, pulling out only the pieces you want. I mean that's key.
Well, anyway, I know it's not a non-trivial project, but it's I think Glenn isn't the only one who's, I think I know Bill Lyle's really interested, and I think one of the original goals of the Tangerine was to have multiple synchronous input receiver. So
Okay.
Nathaniel or somebody else should step up and make sure I'm right about that. But
Yeah, that's absolutely true.
okay. So and it's a simple matter of software for
Simple matter of programming. Yes.
programming. But Glenn is ready to send you the a couple of 888s and all the signal injection hardware, so you wouldn't have to fiddle around with that part of it. You'd have a whole test jig for your work. So if you could find time for that, I could I can connect you up with Glenn. And yeah, I think you'll get something in the mail. So
Okay. All right, guys. I really should go if I'm gonna make this
okay.
other meeting.
Okay.
See ya.
Take care.
Bye.
Nathaniel, I wanted to mention with Franco's Franco's module, the goal of accomplishing, I remember we were discussing in the van to use an RX-888 to emulate a grape system.
Yes.
I believe that with Franco's module, that has pretty much become a reality.
Yes, I absolutely agree with that. I'm very well aware of that. And I think I think what we're gonna see happen is as Bill's, once we get the grape ones going out with Bill's digital RF image, and we get that all set up so that it sends the digital RF data to his server. Once we get those grapes going, then we can work on getting the same sort of thing implemented with the with this RX-888 and the KA9Q software. So yes.
Right. Yeah. This is Franco. Really nice work on this. This is really a
Thanks, Seth.
really big thing to move this project forward. Like light years ahead that it's ever been. So really nice work on this.
Yeah, I absolutely agree. It's incredibly helpful. And I think all of the building blocks are here to use it as in the scientific capacity. I do think as Rob pointed out, we do want to make sure that we have a mechanism for doing the phase locked synchronous channels. And we also do want to make sure that the hardware design we put out does have the GPS discipline as well.
Has anyone been successful with attaching a GPSDO to the RX-888?
I thought either Dave Witten or Rob Robinette or I thought one of those people or Dave Larson.
Glenn N6GN has done it.
Gwen has, okay.
Yeah, Glenn has, and somebody else just sent in a post to my forum, the Whisper Demon forum. I think they did it, and what they did was they just took the Bogner output and put a 50 ohm terminator on a T where the clock signal went into the 888 and said it was completely stable, so that the signal levels were about 1 volt peak to peak with the Bogner set for 8 milliamps of output, and a 50 ohm load. So by terminating of course, it's not terminated down on the PC board of the 888. It's terminated externally. A T connector on the output, or on the input rather. There's a T connector on the input connector. I think he put a SMA to U.FL jumper inside the 888, and he put a T connector on that the SMA that was on the panel of the 888, and had a 50 ohm terminator on it, and then fed it from the Bogner. So it seems that it may be possible that one could daisy chain them. And
Yes, that would work.
As long as everything is close together, that you probably can you can just daisy chain them and terminate them once, and it's a high impedance input inside the 888. So obviously there will be some ringing introduced and so on by the mismatch, but it's the lengths are very short relative to
that short little cable won't.
Yeah, short little cable. So
bother
I think that one Bogner and a bank of 888s, of course, the only reason you need a bank of them is you have multiple antennas. You want to have a 888 per antenna.
Yeah, the big question is, are you going to be able to synchronize the sampling itself?
Well, that's I don't well, if they're all that's what I was speaking to Phil about. That is the technique. There's actually a patent on this technique that has just expired, that HP obtained about now 17 years ago, and it's just expired, which is you apply a stimulus to the inputs of all of the ADCs, and then you look at the output stream and look for that stimulus to appear. So it's a
Do you know if that's how the Kraken or SDR does it?
I don't know how the Kraken does it.
They're synchronizing 5 RTL SDRs.
Yes, I suspect that's what they're doing, but I didn't.
Yeah, I mean that's the way you do it.
Yeah. Well, it seems like a technique that works.
Unless you can actually hardwire.
And
Rob, when Tom Brown said he was from HP Edge, I was wondering if he was familiar with that pattern, with that technique. That's what I was thinking.
That he was familiar with what?
That
Tom.
synchronization technique.
Oh,
I don't. Yeah,
that's a good.
For all we know, he might have been the one who created it.
I'm not familiar with that particular one.
Oh,
I was a little bit involved in very accurate time synchronization over long distance Ethernet, like thousands of miles, and that was patented.
Mm-hmm.
I think I got a patent on the same thing for television. Actually, same idea, which is we statistically multiplexed the compressed video from stations in Maine and Palm Springs and Idaho, and we were able to use NTP, and by carefully standard out of the box NTP, we got, I don't know, it was 500 microseconds. It was well under a millisecond, which was good enough for our statistical multiplexing algorithm. It worked fine, but this one is a different goal. I mean, you have to know exactly where the sample is, right? So where the stimulus appears in the individual sample.
Yeah, because you're trying to do interferometry.
Yeah, so you need to know so I presume what this means is that we have some circuitry ahead of the ADC, maybe even ahead of everything, right on the RF input, which could be switched in, I don't know, periodically, perhaps, and that would introduce a sample, and that sample would be shared between all of the receivers in the pool, and then Phil's software will go look for those samples and determine where they are in each of the output sample streams. And
Tom, what was the
address them.
application you were working with?
Oh, gosh, I have to dredge that up out of my memory.
Might have been astronomy.
No, this was much simpler than that. It had to do with data acquisition systems and synchronizing them. But these were relatively low frequency, up to 50 kilohertz or so typically. But we did want to synchronize to probably to a sample at that sort of bandwidth.
Yeah. Speaking of synchronizing multiple antennas, I like your antenna in the background.
Oh, yeah.
Are any of those still running? Do you know?
I don't think so. That particular one is a picture of Elmendorf Air Force Base.
Right.
There used to be quite a few of them around.
You can still find them on Google Maps or Google Earth, at least the
Right.
ground pattern.
Yep.
That was at Elmendorf in
That was
Anchorage.
Alaska. Yeah. Actually, I stumbled across one not very far from me. So I'm in the Seattle area, and this was up Lummi Island, I think it was, or close to that, up near Bellingham. And I had no idea that there was one up there, but there sure is a pattern on the ground up there.
Yeah, in our work, we've done up to 17 antennas, but not that many. We do direction finding on auroral emissions.
Oh, okay.
Up
Actually,
in
one of the last things that I did at Agilent was they were working on some direction finding stuff, and they wanted a broadband monopole antenna that would cover 20 megahertz to at least a couple of gigahertz. So it's a little short stub of an antenna, but then it has to feed into a very high impedance preamp. And I'd never had trouble with static zap of parts before, particularly. That particular part was a 20 gigahertz FET, and if you looked at it cross-eyed, it would zap.
I'm gonna say 73 for tonight. I keep working on some code. Do you want me to keep the recording going, or should I stop the recording? I can still leave the telecon on.
I don't think you need to record. I don't.
Sounds great.